Okay, so we've been practicing mean. We're gonna step it up a little bit and start solving mean absolute deviation. And so what those things mean, if we break those three words up, mean, like we've been doing, is when you find the average of a set of numbers. So you take all of your numbers, add them all up, find your sum, and divide by however many numbers were in your list. Absolute. We went over it in class, how to find absolute value in your calculator, but it basically just means your distance from zero. So a number's distance from zero, no negatives. So I gave the example of negative 22. The absolute value of negative 22 would just be 22, because that's how far it is from zero. That's how many places it is from zero. And then the word deviation, if you deviate from a plan, you're going away from. Okay, so when we put all that together, if we're given a set of data, and we have to find the mean absolute deviation, it just means we're finding the average distance of each number in the set, the average distance from the mean. Okay, so let's start filling in the blanks. The mean absolute deviation is used to find the average of the distances from the mean. So there's three steps to finding mean absolute deviation. Find the mean of your data set by finding the sum, and then divide by the number of values in the set. So that's just finding the average of the set of numbers you're given. And then step 2, find the distance. Each value is from the mean. And to do that, to find the distance, we're going to be subtracting. And from the mean, which you found in step 1. Okay, then step 3, the last step, is we want to find the mean, or the average, of the distances we found in step 2. So step 2, we're going to be finding a little bit smaller numbers. Step 3, we're taking those smaller numbers and finding the average of them. So twice in this process, you find the average. So the first example, calculate the MAD for the following sets of heights. Okay, so our step 1 is we're going to find the average of all of these heights. So add these numbers up and divide by, there's 10 of them in the set, so we're going to divide by 10. So when I do that, I get 59.1. But just to make this a little bit easier on us, I'm just going to round it to 59. So we'll use this as our mean. So that'll be our first number. Okay, so from there, we want to find the distance from the mean. So that means we're finding the distance of each number in our set and how far away it is from our mean. So when we do that, we're going to be subtracting. So take your first number, 60 minus 59. 58 minus 59. 54 minus 59. 56 minus 59. So you're going to do that all the way down. And when we do this, we're looking for the absolute value. So 60 minus 59 would just be 1. But when we subtract 58 minus 59 in your calculator, it's going to give you -1. But we want the absolute value. So we want just 1. We just want the distance from each number. And so in your calculator, if you solve all of these problems in that absolute value section, when you go to math and num and abs, you can solve all of these in there and you don't have to think about it. If you choose to do it in the main screen, when you're subtracting them, just make sure that you are dropping your negatives after you subtract. If you get a negative answer, drop that negative and just put your digit in there. Okay, so when I subtract each number, I get these smaller numbers down here. Okay, so those are my distances of each number in the set from the mean. So how far away each number is from that average. The last step, step 3, is I'm going to take all of these smaller numbers and I'm going to find the average of those. So I'm going to go in the calculator and I'm going to add all 10 of these numbers up, find my sum, and divide by 10. And when we do that, you should end up with 2.7. And that's your mean absolute deviation. So that means that each point is roughly 2.7 points away from the mean. Or that's the average distance away from the mean, sorry. So on example 2, same thing. We want to find the average of all of these numbers first. Barista A versus Barista B. So we add all those up and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. So it's not always 10, it just happens to be that's how many numbers they gave us this time. So when we do that, you should get 19.9 or 20. For this sake, just so we can get comfortable with decimals, I'm just gonna leave it 19.9. And so then I wanna find the distance from each number in the set. So 19.1 minus 19.9. 20.1 minus 19.9. 20.9 minus 19.9, and all the way down. I'm taking that number away from each and every one. Just remember, if you get a negative in the calculator, drop that negative. After you subtract and you get a negative number, drop it. Okay, so then when we add all those up, 0.8 plus 0.2 plus 1 plus 3 plus 1 plus 0.4, 0.7, 0.5, 0.4. We take the average of those. So we add all those up, and then we divide by 10. And your MAD should be 0.63 or something close to that if you rounded that top number up. Same thing with the bottom. We want to find the average of all these top numbers first. Okay, so for those, my mean altogether, it's 20.01, and I'm just gonna round it to 20. So that's the number I'm gonna use. When I start to subtract, when I find the distance, I'm just gonna use 20. So it's 19.6 minus 20, 20 minus 20, 20.5 minus 20, and all the way down. We wanna find the distance of each one. Remember, if there's any if there's any negatives, knock those negatives out. Just the value, just the numerical value that you get when you subtract. Okay, so that's all my average, or that's all my distances. So that's how far each of these numbers is from my 20 that I got, and then I'm gonna take the average of those. So add all those up, find your sum, and then divide by 10. And again, it's only 10 because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. It's not 10 every single time, just a fluke. So when I do that, I get 0.21. So the barista's coffee that showed less variability would end up being Barista B. His MAD is lower, so that means all of his numbers up here, all of his coffees, were close to your average. Okay, the closer each set of numbers are, or each number is from your mean, the more accurate or valid your set of numbers is. So, and that's a good thing because he's a barista.